Welcome to VW 4.5. Today we're going to be talking about a whole bunch of functions. So you notice this first one, f of x equals x. That's one you should know already. That's just a diagonal line like this. The slope is 1. It's the origin. Pretty standard. Sometimes they call it the identity function because x and y are equal at all times. So for example, 1, 1, 2, 2, 3, 3, 4, 4. All those points are equal. Now for a domain and range, pretty straightforward. It's just all real numbers and for both of them, so we're good there. The absolute value of x, we know the absolute value if it's positive does nothing. So I'm going to draw that part right there. And if you imagine, this is the absolute value of this graph. What happens is the absolute value will take all these negative values and negate them, making it go up here. So it actually creates a nice V like this. And we can see the domain is going to be everything, and the range is going to be 0 to infinity. Now, if you're wondering how I'm doing that, the domain is x, so I'm just thinking left to right. Are there any restrictions? The range is y, so up and down. I can see the lowest point is 0, and it goes up forever, so 0 to infinity. Next, we have x squared. That's going to be our parabola, 0, 0, 1, 1, 2, 4. Those are our standard points, and then, of course, just reflect it. Our domain range. Domain is once again everything, and the range is 0 to infinity, like that. Notice how I'm putting a bracket, because that point is clearly defined. The next is the root function. So we have 0, 0, 1, 1, 4, 2. Notice I'm picking very convenient points to graph here. Our domain and range here. Domain is clearly 0 to infinity, and so is the range. So there are the first 4. Now let's do the next 4. X cubed. So this one, again, plug in points if you're not sure. 0, 0, 1, 1. And then it kind of makes a parabolic shape on the top part like that. And then on the bottom side, negative 1, negative 1. And there we go. That's our standard cubic curve. Now we go to cube root. So cube root, very similarly, let's plug in points. 0, 0, then we have 1, 1. And then if you plug in negative 1, you also get negative 1. So I really want you to know, notice how those 3 points are identical here. Now for this one, notice how I made the curve go up this way? That's because I know the next point is going to be 2, 8. That's going to be all the way up here. So I know I want this curve to be pretty steep. It has to be going up. Versus this one, I know the next point is actually going to be over here. That's going to be 8, 2. Which means when we curve this, this is going to be curved in a much more flat manner. So it'd be something like this. So notice how the cube root and the cubic graph are very similar, except they increase and decrease at different rates, right? This is increasing very quickly. This is increasing very slowly. This is decreasing very slowly because it's a cube root. But the domain and range for both of them, pretty interesting. It's everything because it extends in both directions forever. So we'll finish writing that there. Now I have 1 over x. So this graph you should have hopefully went over in Algebra 1. If not, no problem. We plug in 1, 1. And then we actually want to draw on these asymptotes. X can never be 0 because you can't plug in 0. And y would never be 0 because you can never divide something and get 0 unless the top is 0, which we can see it's 1. So from there we know that this will just keep getting smaller and smaller. And if I plug in numbers less than 1, it'll keep getting larger and larger. And the same thing on this side. So those are going to be your standard points for that graph. Our domain and range, pretty interesting here. Everything except for 0 on both of them. And we can see that on our asymptote. We also covered this graph a while back, so you can review your notes there if you're kind of lost in that graph. And this last one is k. So I made it generic because it could be any number. You just have to know that this is called the constant function, and this is your value of k right here. This is often referred to as the constant function. That's because it's always the same number, so no matter what, it's going to be a horizontal line like that. So those are the basic functions you're going to need to know, and we're going to use them to go into here, analyzing a piecewise defined function. Highlight piecewise. You'll be seeing this a lot in this particular chapter. A piecewise function is basically a function that's broken up into pieces as shown right here. So think of this like a computer. It's saying if you have these conditions met, use this function. If this is true, use this function. If this is true, use this function. So I know it's overwhelming. So to make it easier, what you're going to do is just highlight or circle this part. And I call these fences. So teachers teach in different ways, so I teach it. We're going to draw fences on the points of interest. So whatever number it gives you, -3, 1, we're going to put fences there. And they're going to look like asymptotes, but they are not asymptotes. So here's my fence at -3. Then I have a fence at 1. And notice how this breaks the graph into 3 regions. Region 1, region 2, region 3. That's going to help your brain like organize what equation goes where. If I look at this, it says -2x plus 1 if you're between -3 and 1, which means this equation belongs in region 2, because region 2 is when x is between -3 and 1. If x is 1, it's 2, so that's actually on the fence. So that's actually, I'll put a note, that's on the fence. And this is greater than 1, so that's going to be region 3, which means nothing is in region 1. So we don't expect anything here. So let's try. Let's start by doing, doesn't really matter. I'll do this first one here, -2x plus 1. It's always helpful to start on the fence and then work your way to the other fence. So for example, here's -3. Plug in -3 right here. Notice how you get 7. So that's going to be 3, 7, 3, 7. Now I put a closed dot because it says equal to. Now I'm going to plug in 1 here, and I can say I get -1. This is not equal to, so I'm going to put an open circle right here at that point 1, -1. And I know it's a line, so using my iPad, I'll just connect it, and there we go. Now some people have you do the slope, so you see our slope is -2, down 2/1, down 2/1, down 2/1. You could do that as well, and that's fine. The next one is if x equals 1, we use number 2, which means I just want to put a dot at 2. So that's how you would do that part. So that's how you're defining that. And if x is bigger than 1, use x squared. So again, we always use the fence. So plug in 1 right there, and you get 1. But it is not equal to, which means you put an open circle like that. And then from there, just plug in points. You know, the point is 2, 4, and it's a parabola. So you're going to sketch your parabola like so. And there's your piecewise function. Now again, for your notes, you're always going to put this. Start at the fences. That's the best way to approach these. Now to cap it off, we're going to find these values, f -2, f of 1, f of 2. Now you could look at the graph, or you can plug it in. Either way is fine. It says f of -2, so I'm going to use this equation right here, because -2 is in this interval. Plug it in, I get 5. I could also look at the graph. -2, look at that, 5. If it's 1, I can see it should be 2, or look at the graph, I can see right there. And if it's 2, I should use this equation. So I can see 2 squared is 4, or again, look at the graph. If I go to 2, we're hitting 4. Okay, that's it.